This is Beyond the Business.
The coast is where almost all human activity begins and ends. It is where infrastructure concentrates, with the ports, industry, cities, tourism, trade routes. It is our main interface with the planet's largest system, the ocean. Everything that enters global circulation passes through this line, and everything that leaves out systems eventually returns to it. If we look at the planet structurally, the scale becomes clear. The total length of the world's coastline is estimated at around 1.6 million kilometers. According to global demographic data, almost 39% of the world's population lives within 100 kilometers of that line. This is not a marginal zone, this is where human systems are densest. And it matters because the coastline does not generate pollution on its own. Up to 80% of marine pollution originates on land. It travels through rivers, drainage systems, agriculture, cities, and industry, and accumulates here. The coast is not a boundary between land and sea, it is a convergence zone, a place where everything we do inland becomes visible. This episode is about that interface where global systems touch the ocean directly and where these consequences can no longer be abstracted away. This is the ocean of waste. If the coast is the interface, then the next question is simple. How do we actually measure what is happening there? Because coastal pollution is not one thing, it is not one number. It is a stack of impacts that arrive from different systems and accumulate in the same place. The most visible layer is a solid waste, especially plastic. One of the clearest indicators here is mismanaged plastic waste. This is plastic that never enters a controlled collection system, meaning it has a high chance of leaking into the environment and eventually reaching the ocean. It matters because it connects directly to the coast, it is easy to understand, and it maps well. But it is still a proxy. It shows the risk of leakage, not the exact amount already floating in the sea. To see the actual flow, you need a second lens. That is riverine plastic input. How much plastic reaches the ocean through rivers? And this is where the narrative becomes uncomfortable because it shows how concentrated the system really is. Most plastic does not arrive evenly from everywhere. A large share comes through a limited number of rivers, especially major river systems and megadeltas. In other words, coastal pollution is often the visible footprint of inland logistics, waste handling, and urban systems failing upstream, and then exiting through a few physical choke points. Then we move from what we can see to what we usually don't. The second layer is a chemical impact, and here the shoreline becomes a different kind of convergence zone. A key indicator is nutrient runoff, mainly nitrogen and phosphorus, from agriculture, wastewater, and industry. On land, these nutrients looks like productivity. In water, they become overload. They trigger eutrophication, algae blooms, and oxygen loss, which leads directly into the next measurable outcome, hypoxic zones. Coastal areas where oxygen drops so low that marine life cannot function. This is not dirt in the water, it is a system response. The sea starts behaving differently because the inputs cross a threshold. Then there is an oil and hydrocarbons. Here there is the important point is that coastal impact is not dominated by spectacular accidents. A lot of the long-term signals comes from chronic operational pollution. Ports, terminals, ship repair yards, routine transfers, and coastal industrial zones. Not as a catastrophe, but as a repetition. Small amounts that accumulate into a persistent footprint. And once you see the indicators side by side, a pattern appears. The coast is not polluted because it exists, it is polluted where it works. This is why broader metrics include what we can call structural drivers. One is the coastal population density. Nearly 39% of the world's population lives within 100 kilometers of the coastline. That concentration multiplies everything: waste streams, wastewater loads, industrial activity, and logistics intensity. Another is port and industrial clustering. If you want a fast proxy for coastal impact, look at where ports, terminals, and industrial zones stack tightly along the shoreline. That is usually where the interface becomes overloaded. And because these impacts are multi-layered, same frameworks try to compress them into composite indices. The Ocean Health Index, for example, rolls different dimensions together: pollution, biodiversity, ecosystem services, and human impacts. It is useful as a narrative lens, even if it cannot replace direct measurement. On the UN side, UNEP's regional marine pollution work provides another layer. Not one global number, but regional assessments and indices that highlight where impacts concentrate, such as the Mediterranean, the Baltic, and the Gulf region. These indices are not perfect, but they make one thing operationally clear: coastal pollution is measurable and it is not random. It follows system geometry, rivers as delivery channels, ports as operational nodes, population density as multiplier, and chemistry as a delayed response. So when we say the coast is the interface, this is what we mean in real terms: a measurable convergence zone where human systems show their full footprint in plastic, in nutrients, in oxygen loss, and in chronic operational residue. Once we understand the coast as an interface and once we see how impact accumulates there, the next question is unavoidable: who is actually responsible at that interface? Because this is where the system becomes asymmetric. Legally, the coastal zone looks very clear. Up to 12 nautical miles from the shoreline, the sea falls under national jurisdiction. This is where domestic law applies alongside international conventions. On paper, it is the most regulated part of the ocean, and yet this is exactly where responsibility starts to fragment. Shipping enters the coastal zone as a guest system. Vessels are required to comply with the international conventions, national regulations, port state control, reporting, inspections, and documentation. Discharges are regulated: grey water, sewage, oily residues, and garbage, all categorized, limited, monitored. Loss of equipment is reportable, incidents are traceable, non-compliance is punishable. The logic is clear: the ship is visible, mobile, and accountable. Now compare that with the land-based system. Cities, agriculture, and industry discharge into the same coastal waters, but through pipes, outfalls, rivers, and underwater infrastructure. This flow is continuous, diffuse, and often invisible. Even when treatment exists, the system assumes dilution as a solution. Not elimination, not recovery, but dispersion. From a regulatory perspective, this creates a blind spot. What arrives from land is framed as a background. What arrives from ship is framed as activity. Same water and different accountability. This is not about blaming states or cities, it is about structural asymmetry. Land-based pollution enters the coastal zone as an outcome of permitted systems: urban drainage, agricultural runoff, industrial discharge. Shipping enters as an actor that must prove innocence at every step. The paradox is simple: the system that delivers the majority of pollution is structurally diffuse. The system that delivers a smaller share is structurally traceable. And traceability attracts regulation. This is how responsibility starts to leak, not because rules are missing, but because they are applied unevenly. This becomes very visible in practice. Lost fishing gear in coastal waters rarely triggers investigations. Abandoned nets, buoys, lines, they stay where they fall. Urban outfalls sit permanently below the surface. They are engineered to be unseen. Their impact accumulates slowly, chemically, and biologically. Ports themselves operate as both regulators and contributors. They enforce rules on visiting vessels while hosting industrial activity that feeds into the same water body. Nothing here is illegal, but the system is not closed. So the 12 nautical mile zone is not just a legal boundary. It is a fault line between two logics: mobile systems that must account for every action, and fixed systems whose impact is normalized as infrastructure. The result is not zero pollution, it is redistribution of scrutiny. Ships become symbols of impact because they can be pointed at. Land systems dissolve into aggregates and averages, and the coast absorbs both. This is not an argument against regulation of shipping, it is an argument for systems integrity. Because if responsibility is not symmetric, optimization will be not systemic. You cannot clean an interface by regulating only what moves through it while treating what flows into it as a background noise. The coast does not care where pollution comes from, it only records the sum. And until accountability reflects that reality, the interface will continue to carry the imbalance. Not as a crisis and not as a scandal, but as a quiet, permanent accumulation. Until recent, coastal pollution was described as accumulation. Things arriving at the shore, flows coming from elsewhere, but a deeper change is already underway. The coast itself is no longer static. It is being redrawn, not only by erosion, not only by rising sea levels, but by deliberate human expansion into the sea. For most of history, the coastline was a limit, a physical boundary where land systems ended and marine systems began. That logic no longer holds. Today, the coast is treated as a platform. Ports pushed outward, terminals extend seaward, industrial zones are built on reclaimed land. Logistics hubs grow beyond the original shoreline. And this is not accidental, it is driven by scale. Larger ships require deeper drafts, higher volumes require more space, global trade demands buffering, redundancy, and storage. Land runs out, so the system does the obvious thing. It moves into the sea. This is where the logic shifts. Pollution used to radiate from points, a river mouth, a port, an outfall, but once the coastline itself expands, impact is no longer radial. It is embedded. Nuke waves alter currents. Reclaimed land reshapes sediment flows, dredging permanently increases turbidity. Shallow ecosystems are buried and not polluted. Nothing spills, nothing fails. The environment is simply overeaten. Every extension of the coastline multiplies activity. More terminals mean more ship calls, more dredging, more underwater noise, more operational discharge, and more maintenance. Industrial zones built on reclaimed land sit closer to the water than anything before them. They create new sources of runoff, heat, chemicals, and waste, not leaking toward the sea, but placed directly inside the interface. The system doesn't just add impact, it relocates it. What used to be offshore becomes coastal. What used to be coastal moves inland. The boundary shifts. This is the critical point. Coastal expansion is not a failure of environmental policy. It is a success of logistics optimization. Bigger ships, faster turnaround, higher throughput, lower unit costs. The coastline absorbs the spatial cost of that efficiency. And unlike pollution, this change is hard to reverse. Water can be cleaned, discharge can be reduced. A coastline cannot be easily unbuilt. Once land is reclaimed, once depth is altered, once sediment flows are rerouted, the system does not return to baseline. It adapts permanently. Here the feedback loop tightens. Human systems expand into the sea while the sea expands onto land. Reclaimed areas sit low, they require constant protection, barriers, pumping, and reinforcement. Infrastructure becomes more rigid at the exact moment the environment becomes more dynamic. Storm surges travel differently, flooding propagates faster, failures cascade across ports, cities, and supply chains. The coast is no longer just exposed, it is engineered into vulnerability. Coastal change is not only about pollution and it is not only about climate. It is about geometry, about how far systems are pushed outward without accounting for how the ocean responds inward. The coast stops being a line, it becomes a moving zone reshaped by trade, logistics, and infrastructure decisions. And once that shift is understood, the question changes. Not how do we protect the coast, but how long can it keep being redesigned without destabilizing the system it connects to? To understand what is happening to the coast, we don't need abstract models, we need to look at decisions. And not historic ports, not legacy damage, but places where coastlines are being rebuilt now with a full awareness of climate risk, ecological impact, and long term uncertainty. Let's start with the Tuas megaport. Singapore is not expanding because it lacks regulation or data. It is expanding because the system demands it. Container ships are larger, volumes are higher, land is limited. Competition between hubs is unforgiving, so the solution is logical move outward. Tuas is not just a new port, it is a complete relocation and expansion of the coastline itself. Reclaimed land, deeper waters, new geometry. This is not environmental neglect, it is logistics optimization. The coast is reshaped not because risks were ignored, but because growth was prioritized. Now shift lens to China, not to old industrial belts, but to new coastal industrial platforms like Dalian Changxing Island, petrochemical zone. Here the coast is no longer just an interface for trade, it becomes a production surface. Petrochemical complexes, energy terminals, heavy industry all clustered at the shoreline because water access lowers costs, simplifies transport, and stabilizes supply chain. This is not pollution by accident, it is design. The coastline is expanded, stretched, reinforced, and industrialized because it makes economic sense. Ecosystems are not disrupted by failure, they are replaced by infrastructure. And then there is a Fujairah port. Here the driver is not volume or manufacturing, it is security. Fujairah grows because it sits outside the Strait of Hormuz. Fuel storage, bunkering, and terminals are moved there to reduce geopolitical exposure. Again, the logic is clear. And again, the coast absorbs the cost. New terminals appear where there is space, depth, and access, not where ecological impact is minimal, but where operational risk is lower. Across these three cases, the pattern is the same. Expansion is justified by growth, by efficiency, by resilience of supply chains, and by the need to handle volatility, weather disruptions, rerouting, congestions, and delays. But there is a question that rarely gets asked. When these coastlines were redesigned, was the ocean treated as a system to be protected or a space to be optimized? In practice, the answer is visible. Environmental assessments are completed, checklists are passed, mitigations are documented, and then economic logic decides the outcome. The port is built where it fits, the terminal is placed where it works, the zone expands where land is available. So, when currents change, when erosion accelerates, when fish stocks shift, when water chemistry alters, these are not surprises. They are delayed responses. If growth logic keeps winning every time, then we shouldn't ask later why the system changed. The coast did not fail. It was redesigned to serve an economy that measures efficiency in throughput and impact only after the fact. There is another kind of coastal transformation that looks harmless on the surface. It doesn't move containers, it doesn't load tankers, it doesn't claim to be critical infrastructure. It simply creates land, artificial land. The most famous example is Palm Jumeirah. From above, it looks elegant, a symbol of ambition, engineering mastery, real estate logic applied offshore. But from the ocean's point of view, this is not a development, it is abstraction. An artificial island is not placed on the ocean, it is inserted into it. Water does not stop moving, currents don't respect geometry, sediment transport doesn't adapt politely. When land is reclaimed from shallow coastal waters, three things happen immediately. First, circulations slows down. Breakwaters, artificial shapes, and enclosed lagoons reduce water exchange. Stagnation increases. Oxygen renewal drops. Temperature stratification rises. Water that used to move now lingers. Second, sediment dynamics break. Sand doesn't just stay where it is placed, it migrates. It smothers seabeds, it alters turbidity permanently. Habitats are not disturbed, they are buried. And third, biology disconnects. Plankton distribution changes, fish migration routes shifts, spawning grounds disappear, not because of pollution, but because the physical map is no longer recognizable. Nothing explodes, nothing leaks, life simply leaves. And this is not unique to one place. Palm Jumeirah is not an exception. Projects like the World Islands push the same logic further. Geometry for humans, not flow for ecosystems. In Hulhumaleh, land reclamation is framed as survival. Rising sea levels, population pressure, limited territory, the motivation differs. The physical outcome does not. So artificial coastlines behave the same way everywhere. They slow water, they trap debris, they accumulate microplastics, they reshape currents for beyond their footprint, even with the cleaning, monitoring, and best intentions. What sits underneath all of this is a quiet assumption that the ocean can be treated like land. That if we can build on soil, we can also build on water. But land is largely static. Ocean systems are not. On land, you can fence an area, in water, boundaries leak. On land, disruption can be local, in the ocean, it propagates. There is no empty space offshore, there is no neutral zone. Every shallow area already performs a function. When we pour sand into the sea, we are not creating something new, we are deleting something that already worked. Artificial islands also create perfect traps. Reduced circulations means fine particles stay longer. Microplastics accumulate, organic matter decomposes differently, and chemical residues linger instead of dispersing. Even without visible pollution, these areas become collection points. Not because someone dumped waste, but because the system was redesigned to hold it. A coastline no longer behaves like a coast. The most important shift is not ecological, it is structural. Artificial land turns the coast from a gradient into a wall. Instead of transition, you get a blockage. Instead of exchange, you get a retention. And once that happens, the coast no longer absorbs pressure. It reflects it, redirects it, and amplifies it elsewhere. Erosion accelerates downcurrent. Sediment disappears upstream, water quality degrades widely. And by the time questions are asked, the map has already changed. Artificial islands don't just change what we see, they change how the ocean works. And once land is poured into water, there is no rewind button, only a new normal. built on geometry that serves humans inside a system that was never meant to be still. Once the coastline starts moving, another shift quietly follows. Not all expansion looks like ports or terminals. Some of it looks clean, symmetrical, almost elegant. Artificial islands, reclaimed shapes, enclosed marine spaces designed for development, tourism, or prestige. What this project create is not just land. They create aquadomes. An aquadome is not a structure, it is a condition. A semi-enclosed water body formed by artificial geometry. Breakwaters, islands, causeways, reclaimed land. That alters how water moves, mixes, and renews itself. Nothing needs to leak and nothing needs to spill. The system changes because circulation changes. In open coastal systems, water moves laterally and vertically. Currents flush nutrients, sediments redistribute, temperature gradients stabilize. Aquadomes interrupt that logic. Flow slows down, exchange becomes partial, renewal time increases. What used to be a dynamic system becomes a holding space. And whatever enters that space, nutrients, microplastics, heat, and operational discharge, stays longer than it should. This is not a dead zone, and this distinction matters. Aquadomes are not dead zones. Oxygen may still be present, life may still exist. But the system is no longer resilient. It loses its ability to self correct. Impact does not disappear, it accumulates quietly. Why aquadomes multiply impact? Artificial geometry creates new edges. Inner shorelines, protected bays, low energy pockets. These areas become natural collectors. Fine sediments settle, microplastics concentrate, thermal layer persists. Biological cycles desynchronize. What was once dispersed becomes localized. And because these zones are engineered, their effects are structural and not accidental. Designed for stability and vulnerable by design, aquadomes are built for control. Calm waters, predictable conditions, and operational convenience. But that control comes at a cost. The more stable the water becomes, the less adaptive the system is. Stagnation is not failure, it is design outcome. One aquadome is a local change. Many aquadomes along the same coast reshape the entire coastal system. They fragment circulation, redirect currents, and change sediment budgets, and redefine how impact travels. The coast stops behaving like a boundary, it starts behaving like a sequence of enclosed basins. This is the hidden layer of coastal transformation, not pollution as an event, not climate as an obstruction, but geometry as impact. And once water is enclosed, the question is no longer what enters the system, but how long it takes to leave. Up to this point, the coast looked like something we shape. But there is a shift that quietly breaks this logic. The coastline is no longer only something we modify, it is something that is moving on its own, and not suddenly and not dramatically. Sea level rise is a not single event, it is a background process that changes the baseline the coast was designed for. And that matters because most coastal infrastructure is built on one assumption that the reference level is stable, but it no longer is. There are two mechanisms that matter here. The first is simple physics. As the ocean absorbs heat, it expands, not at the surface, not as waves, but as volume. This expansion is slow, cumulative, and inertial. Once it starts, it doesn't stop when policies change. The system remembers the heat it has already taken in. The second mechanism is mass. Ice that used to sit on land, glaciers, ice sheets, is turning into water that enters the ocean system. That is not redistribution, that is addition. And the important part is this: these processes don't play out evenly. Sea level rise is not uniform. It accelerates in some regions and lags in others. Currents, temperature gradients, and basin geometry create local amplification, which means the coast does not experience global averages, it experiences local reality. In parts of the Pacific, entire island systems are watching their shoreline retreat without storms, without disasters, just with time. Low elevation, porous ground, saltwater intrusion. Not a collapse, but a progressive loss of living conditions. In densely populated deltas like parts of South and Southeast Asia, the effect stacks. Rising sea level means sediment loss, subsidence, and human extraction. The water doesn't just come from the ocean, it stops draining back. And then there are places like the Netherlands, often cited as a proof that engineering can solve the problem, and it does technically, but only through constant reinforcement. Higher barriers, more pumping, continuous intervention, which tell us something important. Even the most engineered coast does not solve sea level rise. It manages permanently. This is where the contradiction appears. At the same time as sea level rises, we are expanding coastal infrastructure outward. Reclaimed land, new terminals, low elevation logistic zones. In other words, we are fixing the coastline in place precisely when the system it borders becomes more dynamic. That creates a structural mismatch. Infrastructure becomes rigid, the ocean becomes mobile. And rigidity in a moving system is not resilience, it is fragility. Storm surges propagate differently, flooding travels faster, failures cascade across ports, cities, and supply chains. Not because something went wrong, but because the baseline quietly shifted underneath everything. Sea level rise is not just an environmental issue, it is a design issue. It tells us that the coast is no longer a line, it is a zone in motion. And when we continue to design ports, cities, and industrial zones as if that zone were fixed, we are not adapting. We are locking systems into geometry that no longer exists. The question is no longer how do we protect the coast? It is how long can we keep building permanence into boundary that is no longer stable? And that question doesn't belong to climate policy, it belongs to systems design. So, what does all of this really point to? Not to another call for protection, not to better barriers, not to stronger walls. What we see along the coast is not just damage, it is a signal. A signal that systems designed for stability are now operating inside a moving boundary. We keep expanding coastlines, optimizing ports, reclaiming land, and enclosing water, as if the baseline were fixed. It isn't. This is why adaptation on its own is not enough. Adapting means adjusting to what has already happened. It means locking systems into responses instead of changing their trajectory. What the coast is asking for is not adaptation, but foresight. Design that assumes movement, infrastructure that expects change, decisions that start upstream before geometry hardens, before water is enclosed, and before impact accumulates. Because once the coast is rebuilt, once circulation is altered, once the system is fixed in place, there is no quick correction, only management of consequences. The coastline is not a problem to solve, it is an early warning surface. And the question it raises is not how do we protect it, but whether we are still designing as the future was predictable.